regression lines. Example 2. We want to investigate the time taken for these weed killer pellets to dissolve in water for different temperatures. So we can see there's a negative correlation between the time taken in minutes and the temperature of the water in degrees Celsius. The regression equation for this data is given. The raw data is not given. We don't have a table of time and temperature values. And we can see there's strong negative correlation between the time and temperature. Okay, so first question, why does t equals 48 minutes, this point, have no meaning? And for this point, if you come straight down and look at the temperature, it's 0. And water at 0 degrees, well, it's ice. And the pellets are not going to dissolve in the ice. And what you'll see from the graph, there's no data point on here at this position here where the time is 48 minutes and the temperature is 0. We've extrapolated that line to get to this point on the graph. What's the interpretation of the minus 0.7 in the regression equation? So it's the decrease, because of the minus, the decrease in time taken to dissolve for every 1 degrees Celsius increase in the temperature of the water. Part 3, we want to estimate the time taken when the temperature is 30 degrees. So we can substitute 30 into the equation and work out the time, which gives us 27 minutes. So is the estimate reliable? Well, we're using interpolation because 30 degrees here is within the range of our data. We have strong negative correlation. The variable we want to estimate, time, is on the vertical axis, as it should be, which means overall we have a reliable estimate. Part 4, to estimate the time when the temperature is 90 degrees. Now 90 is out here somewhere on the graph, so we're extrapolating, and you can see we get a ridiculous value for the time taken when we substitute 90 into the regression equation. So because we're extrapolating, the estimate is unreliable and it's a meaningless value anyway. Part 5, we want to estimate the temperature. Now, the variable we want to estimate always goes on the vertical axis, so this is the wrong way around. So can we do this? Can we stick to that regression equation and just substitute in 40 minutes? Are we allowed to do this? Can we just rearrange this equation now to work out t? Now we can't do that. What we need to do is exactly what it states here. The variable to estimate must be on the vertical axis. So let's scrap this and do a new scatter graph with temperature against time, and then work out a new regression equation, and then use this to estimate the temperature. That would be the correct method. For further practice, try these questions.